Welcome to Eureka Math. I'm Mr. Schenkel. This is Grade 8, Module 4, Lesson 11. Let's get started. Okay, we're going to take the situation, we're going to write a linear equation to match it, and we've been working on some ways to do that in class, so we're going to go through these and get some more practice in getting this job done, and we'll put it in the table and we'll graph it to show you the linear equation, the linear line that's created from the equation. All right, Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? Well, let's start with writing a ratio, and the ratio I'm going to use is it's going to be for my constant. And the constant is going to always be equal to the dependent variable over the independent variable. So in this case, the dependent variable is the amount of square feet of the lawn that she can mow, and that's going to depend on how long she mows. So I want the square feet of the lawn first, so that's going to be 35 square feet. And over the amount of time that it takes her, which is 2.5 minutes. And then I want to create another equivalent ratio that also compares square feet to minutes. And in order to write the equation, let's do that first. I already have that. I have my y over x here. So we're going to use the means extremes, and I'm going to start with the dependent variable because I want that to be on the left side of my equation. So I get 2.5y. 2.5y is equal to 35x. 35x. And now if I simplify and isolate the y, that will give me my linear equation. The linear equation we know is always going to start with y equals something. So if I can get my equation to read y equals something, then we'll have our answer. So I'm going to divide by 2.5 or multiply by that reciprocal. But divide by 2.5 in this case is easy. So we get y equals, and then 35 divided by 2.5. So let's do that on the calculator. 35 divided by 2.5 is 14. So y equals 14x. And that's our linear equation. Y equals 14x. That's going to tell me the number of square feet that she can mow no matter how much time has passed. So if we use the table, then we could say, well, if I don't mow at all, 0 minutes, then I would get y equals 14 times 0, and 14 times 0 is 0. So if I don't mow at all, if I spend no time mowing, I'll get 0 square feet mowed. And that's logical. If we put in a 1 minute of mowing, then we get y equals 14 times 1, and 14 times 1 is 14. So after 1 minute, we get 14 square feet of lawn mowed. If we work for 2 minutes, then we have y equals 14 times 2, and 14 times 2 is 28. So 28 square feet of the lawn will be mowed. And we can continue. 3 is y equals 14 times 3, and that's 42. And then for 4 minutes, y equals 14 times 4, and that is 56. All right, if we wanted to answer this question, how much lawn could she mow in 10 minutes? Well, we just plug in a 10. So that would be y equals 14 times 10, and 14 times 10 is 140. And so we can use the equation to calculate any amount of square feet of the lawn that will be mowed. We can also graph that on our coordinate plane, and if we do that, our X value is the first column, our Y value is the second column. And we get a 0, 0 ordered pair. And then the next one would be a 1 in time is 14 in square feet. 2, 28 would be about there. 3, 42, right in there, right in there. 4, 56, and that one's going to be about right there. And then that should be a straight line. If I start from the 0, 0, we should get a straight line right through all of those points, and we do. Because the equation is linear, creates a straight line, and that is our first example. Let's look at the next one. Water flows at a constant rate out of a faucet. Suppose the volume of the water that comes out in 3 minutes is 10.5 gallons. How many gallons of water come out of the faucet in t minutes? Well, we need our equation, so I'm going to set this up. My dependent variable is going to be the volume of water, and that's 10.5 gallons. So I'm going to start with 10.5 gallons over the amount of time it takes for that to happen. They told us that was 3 minutes. So 10.5 gallons in 3 minutes is our rate. And then we want to set that equal to our dependent variable, which is going to be V. They told us down here, V is the amount of gallons. So V over the amount of time, and that's T minutes. So I have gallons per minute. I have a proportion. Then I can use the means extremes and come up with our equation. So I'm going to start with the dependent variable. I want that to be first, so that can be on the left side, because we always know it's going to be our dependent variable is equal to, that's going to be the start of our equation. So we get 3V is equal to 10.5 times T. So 10.5 T. And then I want the V to be all by itself, so I'm going to divide by 3 and balance the equation. That gives us V equals 10.3 divided by, 10.5 divided by 3. 10.5 divided by 3 is 3.5. So that is our equation. V equals 3.5 T. V equals 3.5 T. And now we can plug in our independent variable, which is given to us this time. If we have a 0, this would be V equals 3.5 times 0, which is 0. If we let the faucet run for 0 minutes, we'll get 0 gallons. V equals 3.5 times 1, that's 3.5. So if we let the faucet run for a minute, we'll get 3.5 gallons. V equals 3.5 times 2, that's 7. V equals 3.5 times 3, that's going to be 10.5. That was given to us. And then finally, V equals 3.5 times 4, and that is 14. And then we can use those ordered pairs to graph on our coordinate plane. 0, 0 would be here. 1, 3.5 is there. A 2, 7 is there. 3, 10.5, right in there. And a 4, 14 would be here, there. And then we should see that line. Yeah, all of those points line up, and it's a linear equation. Next, exercise 1. Juan types at a constant rate. He can type a full page of text in 3.5 minutes. We want to know how many pages Juan can type after T minutes. All right? Well, again, I'm going to take the rate that they gave us, and that was 1 full page of text in 3.5 minutes. And it's given to us, but we can think about this also. This is given. That's the dependent variable, the number of pages. The number of pages typed will depend on how many minutes Juan types. And the number of minutes Juan types will determine the number of pages. So pages is dependent. I want that first. and the number of pages is one full page, over the amount of time, t, and that's 3.5 minutes. So there's our first ratio, and then I just want dependent variable p over independent variable t. And now I can use the means extremes to isolate our dependent variable. So I want to go here first. That's 3.5p is equal to 1 times t is t. All right, and then we just need to isolate the p. So I'm going to this time multiply by the reciprocal and do that same thing over here. It's the same as dividing. That gives us p equals, the number of pages is equal to 1 divided by 3.5. Well, I'm going to try that. 1 divided by 3.5. If I do that, I get a run-on decimal. So I don't want to change this to a decimal, but I can't have 3.5 in the denominator. So I'm going to clear that decimal. And this time I can just do that by multiplying both of these by 2. So multiply the top by 2, multiply the bottom by 2. And that's, in effect, multiplying by a number 1. So I'm not going to change the value. 1 times 2 is 2, and 3.5 times 2 is 7. So that's 2/7 t. And that's our equation. P equals, the number of pages is equal to 2/7 times the amount of minutes, t. Okay, and then we can plug that in and get our dependent variable for our independence that they gave us. And the first one was a 0, so 2/7 times 0, that's 0. If we put in a 5, we get p equals 2/7 times 5, that's 10/7. Okay, if we put in a 10, p equals 2/7 times 10, that's 20/7. If we put in a 15, that's p equals 2/7 times 15, that's 30/7. And then lastly, p equals 2/7 times 20, that's going to be 40/7. And then we can graph. Now, I don't know exactly what 10/7 is, but I can use a calculator to give me an idea. 10 divided by 7 is around 1.4. So if I have 5 minutes, 5 on my time interval, the x value, and then up 1.4, well, it's somewhere in the middle. I almost forgot the 0, 0. 10 on my time interval, and 20/7, well, if I use a calculator, 20 divided by 7, that's about 2.9. So 10 on my x-axis. 2.9 is almost a 3, so right up in there. The next one is 30/7 with a calculator. 30 divided by 7, about 4.3. So 15 to the right, 4.3 up. Let's see if I can get that somewhere in there. It's pretty close. And then the last one, 20 to the right and 40/7. 40 divided by 7 gives us a 5.7. So 20 to the right, 5.7 up. It's almost to the 6, so somewhere in there. And we should see a line that connects all of our points, and we do. I might have missed my line by a little bit. But that's a linear equation, and again, just setting it up using the dependent variable over the independent variable to create the equations. Let's try number 2. Emily paints at a constant rate. She can paint 32 square feet in 5 minutes. Okay, so 32 square feet in 5 minutes. I want 32. Let me get the correct pen. 32 over 5, that's dependent over independent, And then I want to set that equal to my dependent variable is a over my independent variable is t for time. And then means extremes. So let's see, we've got, I want my dependent variable to be first, so I get 5a is equal to 32t. And then I want to isolate the a. So divide by 5, both sides. A equals 32 divided by 5. Let's check that, see if we can use a decimal. We can. It's just 6.4. So I can write that exactly, 6.4t. That's our equation. Area is equal to 6.4 times the amount of time in minutes. All right, and then again, substitution. Area equals 6.4 times 0. Well, that's 0. If we paint for 0 minutes, we get 0 area painted. Area equals 6.4 times 1. That's a 6.4. Area equals 6.4 times 2. 6.4 times 2 would be 12.8. Area equals 6.4 times 3. 6.4 times 3, that's going to be 19.2. Just check it to make sure I'm not giving you the wrong number. 6.4 times 3, 19.2, right? Area equals 6.4 times 4. So every time, all I'm doing is substituting my independent variable for t and then calculating. So this is going to be 25.6. Graphing 0, 0. And then if we have 1 minute, we get 6.4. That's going to be somewhere in there. 2 minutes, 12.8. Close to the middle, somewhere in there. 3 minutes, 19.2. It's almost to 20. Maybe a little higher. 4 minutes, 25.6. About halfway, so somewhere in there. All right, then we'll check our line. Yeah, pretty good. There's our linear equation, the graph for our linear equation, a equals 6.4t. All right, one more. Joseph walks at a constant speed. He walked to a store that's 1/2 mile away in 6 minutes. So let's see, 0.5 miles in 6 minutes. There's my rate. And I just want my dependent variable first. That's m for miles. Over my independent variable second is t for time. Means extremes. 6 times m is 6m is equal to 0.5 times t is 0.5 t. Divide each side by 6. We get m equals 0.5 divided by 6. 0.5 divided by 6 is a run-on decimal, so I don't want to use that. I want to change this. So I'm going to multiply by 10. So I'm going to multiply by 10 over 10. That's going to clear that decimal. And I get 0.5 times 10 is 50 over 60. 5 over 60, my bad. 0.5 times 10 is 5 over 60. There we go. And I can simplify that. They can both be divided by 5. 5 divided by 5 is 1. 60 divided by 5 is 12. So that is our coefficient, 1/12 t. Our linear equation, m equals 1/12 t. Then we go about plugging in our independent variables and solving for the dependent. So 0 is 0. 30, so that's going to be m equals 1/12 times 30. times 30. So that's 30 twelfths, or 30 divided by 12 is 2.5. Okay, let's put a 60 in. M equals 1/12 times 60. And 12 divided by 60 is 5. M equals 1/12. I said 12 divided by 60. 60 divided by 12 is 5. 1/12 times 90. So that's 90 divided by 12. 90 divided by 12, 7.5. And the last one, M equals 1/12 times 120. And you can see a pattern here. We're just adding 2.5 each time. So another 2.5 would be 10. Then we can graph 0, 0. 30 to the right, up 2.5, somewhere in there. 60 to the right, up 5, halfway in between 4 and 6. 90 to the right, up 7.5. 7.5 almost to 8, somewhere in there. 120 to the right, up 10. That one I've got an intersection for. And then our line should be right along all those points, and it is. Linear equation, M equals 1/12 t, looks like that. All right, that is lesson 11. I hope that helps. I'll see you again next time.